Okay, I'm going to start. Short audience. Welcome, guys. This talk is about vSwitch and DPDK support in CloudStack. A little bit about me. My name is Nicolás Vázquez. I'm from Montevideo, Uruguay. I work at ShapeBlue as a developer. I mostly do design and implement features for CloudStack. Just joined the company 2 years ago and joined CloudStack in 2015. So been working for some years in the community and also became a committer in 2016. So very briefly, this is what I'll be presenting today. A very brief introduction to vSwitch and DPDK and how are we supporting that in CloudStack. Mainly in 4.12 is the initial support, and then in 4.13 there are some extensions. So let me quickly start by a really fast introduction to vSwitch. vSwitch is a virtual switch solution. It's open source. It allows to make fast packet processing by passing packets from user space to kernel space. Let me show you a very brief diagram. In this diagram, you can see the switch. Basically, what you have a table in kernel space, which will be the fast one, and if packages incoming to the NICs do not match that table, then we go into user space to processing, and then that table will be populated again. So you see, you can have a better performance than native bridges. But yeah, there's this passage between user space and kernel space, which can be improved, and that's why we are introducing this feature with DPDK. DPDK is a library written by Intel, which actually it's a set of libraries for fast packet processing. So what we'll see here in this diagram is that having your vSwitch solution with DPDK makes performance increase a lot, like 10 times, as we can see here, with one thread and two threads. 10 times or 12 times on throughput performance. And that is because DPDK has these PMD drivers, which are mode drivers, which basically bypass the network stack for those packages, which is a limitation for vSwitch, and that makes the performance to increase a lot. So as I mentioned, that is a chart or for some performance made. What I forgot to mention, this feature will be targeted only for KVM and vSwitch. And basically this support is based on additional VMs configuration. This is a new feature in CloudStack, which has been recently added to 4.12, and it basically allows you administrators or to pass whatever you want to a VM deployment. It can be done on deployment time or in update VM, stop VM. So it supports the main three hypervisors, KVM, VMware, and Sun Server. So depending on the type of the hypervisor, you can pass the additional configuration. So for example, on KVM, you can pass a piece of XML that will be included on your VM. And then VMware, you will pass like a key value pair that will be added to your VMX file, and that's it. And with Sun Server, you will use the add parameter X API. So you see, it's very flexible, as you will control whatever you want to be included on your VM and what can be enabled, and that's pretty nice. All that metadata is sent, as I mentioned, on deployment time, or can also be an update time. So I have an example there in which, no, not on this one, sorry. The way it's done is with the existing APIs, there's a new parameter, which is extra config, that needs to be encoded. So it needs to be encoded because it allows multiple parameters to be passed. So as passing those parameters, those can have a name and will be stored in CloudStack internally on the database as VM details, and then will be sent to the KVM host or passed as the as the VMX file, depending on the hypervisor. So here, now yes, I have the example. So suppose I want to pass some metadata to a certain VM, and for KVM, this is a piece of XML. If I just encode it, I'll get that not very nice string, but that is how CloudStack will receive it as a single parameter, the extra config parameter. And let me, I wanted to show you, but sorry. I'll do that later. So, yeah, then CloudStack will update database and send, not this, but that piece of XML will be included on the domain XML of the VM, on this KVM VM. So I will show you later, but there is also the possibility to store that on service offerings, so you don't have to do that for individual VMs. The support for service offerings is from the next major release, which is 4.13, but 4.12 includes the individual VMs additional configurations. So keeping that in service offerings, you'll see the advantages, because it's more secure for administrators to actually set the configurations on a service offering, and then users will just select the service offering for their deployment. The way it's done for service offerings, it's simply being added as details, service offering details, following the same format as I'm going to show you now. So yeah, in case you have the very same property to be added from your service offering and also from your VM deployment, then the VM instance details will take precedence over the service offering ones. Okay, so now the funny part will be to test this. Yeah, basically, sorry. Yeah, as you'll see, if I do select some, I don't know if you can see there. Oh, no, sorry. Let me increase. Is it better? Okay. Let me increase a bit more. Okay. So you see, this is the extra config parameter, and what I basically have here is the URL encoded string, the one that I placed on the slides. So yeah, if I pass it here to as the extra config parameter, I want to show you two things. The first is, yeah, this new VM 22. If you go to the host, yeah. So yeah, that gets included. So you see, you basically can pass anything and will be just included on the main XML. It only has to be encoded previously. That is a bit tedious, but yeah, I think it's a good thing to have and as flexible. Let me continue.
So if you want to do this is like one-time configuration you do, and all the VMs can use the DPDK.
Yeah, I still haven't talked about DPDK, but okay. I'll do that shortly. I mean, these additional configurations can be anything. Like the one that I have added recently is just a metadata tag, which has some parameters, and that got included. So let me show you again.
So is it only for top-level domain XML stuff, or can it override existing things, or
and it won't override. It will just try to add it.
It's specifically in the metadata.
Yeah. Specifically.
You can't add devices and things like that to XML. It's just the metadata.
No, you can. I'm going to show you. Okay. If you want, you could. CloudStack will not check for that. That is a current limitation. You will be able to pass anything if you want to the update. If you wanted to add a device in the proper format, then you will be able to. That's. We are supposing that everything that gets passed is properly. It's not causing problems, but yeah, could maybe because as it is plain text, there's no easy way to check. I mean, that could be improved, but should be for future work. But my point here is I'm not talking about DPDK now, but just a general thing in CloudStack that can add things to your deployments.
Like automating the configuration.
Yeah, extending the current VM configuration for whatever you want. So you don't have to do that manually. You can do it one time on your service offering, and then all of your VMs will get that.
Is there an XML sanity check on that, or will it just break if it's wrong or syntax?
Yeah, as I mentioned, that it's a limitation. You will break if it's wrong. And, yeah. Currently, you need to be. You have to do your checks before. Yeah. So let me go back. Okay, now the DPDK support. I have previously introduced the additional configurations because DPDK support will use it. So there are some certain configurations that need to be passed. I'm gonna be talking about that later. Basically, what I will start with is the agent configuration. So as this works on KVM, your KVM agent, CloudStack agent needs to be aware that you want to support DPDK, and you also need to configure it. So your first steps need to be, of course, having an open vSwitch networking, and on top of that, make sure that your OVS version supports DPDK and have DPDK installed. What is very important to work with DPDK is that your wishes gets created with the netdev data path. That is a requisite. And also your QEMU and libvirt versions need to support huge pages, which is something that DPDK needs. So that's why we also need to have it on your KVM hosts. In terms of the CloudStack agent, there's a new property. There are two new properties that need to be added, which are DPDK enabled, just a true or false flag, and the open vSwitch path. This path will tell CloudStack where's the path for your open vSwitch bridges, because the main goal of this feature is to create your OVS ports with DPDK support.
Now, is this the OVS Vif driver? Does it read these?
Yeah, the OVS Vif driver is extended with this. So it's using that. Actually, when you in the VM domain, the interface references the port and uses the path. So that's why you need to explicitly say where it is. Okay, so in a very high level scheme or diagram, DPDK supports needs two configurations that needs to be added. The huge pages, as I mentioned, and CPU and NUMA, those are the two configurations that need to be passed. And whenever those two configurations need a special name, which I'm going to show you in a few seconds. So the CloudStack agent will know that should be a DPDK enabled VM. And why should it know? Because if not, the CloudStack host, the KVM host, will just create an Open vSwitch normal port, and you won't have that throughput improvement that I've talked about. So in order to enable that and let the host create the infrastructure for you to have this improvement, you need to pass those two configurations. And you can do it as I showed you today through service offerings or individual VMs, additional configurations. So yeah, the way that CloudStack is creating these ports is using a prefix, the CS DPDK. Those are created with the DPDK support, so you can have that improvement. You'll see the host get those ports created, and your VM interfaces, once this is enabled, will get the host user type, and will use, as I mentioned, the path to reference the ports. So that's the main difference with normal Open vSwitch support with KVM in CloudStack. Now I'm going to show you very briefly. Very big. So let me show you. This is CloudMonkey. If I do list service offerings, I have previously set a service offering here with some extra details. So you see huge pages and NUMA configurations. Those have been previously added by me on the service offering. So I will just do a very simple deployment from the UI, selecting the service offering previously created, so the DPDK test. Okay, and just as simple as that, the KVM host will be aware that it has those properties and needs to create the proper ports. So yeah, there we have our instance. It is 23. So if I examine on the host version list, yeah. Yeah. First of all, the additional configurations, the huge pages gets here, and the NUMA support gets also created. But what I wanted to show you here is the interface part. This is the actual change with previous Open vSwitch ports. So you see also the interface type is the host user, and it used by default I have here bar and Open vSwitch, but it's where the port got created. So let me also show you. It uses CES DPDK2 because yeah, you'll see here. All your other ports and the CloudStack DPDK ones, which I have another VM here, but are DPDK vhost user types. So the VM gets this port reference and can use the functionality from OBS and DPDK. And that's as simple as that. Is you can have your VMs do that with this functionality. What else? Right. So from what I have shown you until now, that is the support for 4.12, just the DPDK support. Starting from 4.13, we have done another improvements on this feature, which allows the administrator to select the vhost user mode. Basically, that's a client-server model between QEMU and OBS and DPDK. So it refers to which one will actually create the port. If QEMU will behave as a client or as a server, validate for each interface in the VM, and will connect to, always the connection is between client to server. But this can be controlled same as we have seen in the service offering. So there is a special service offering detail, which is DPDK vhost user, which can also be added as simple as that, as a service offering detail. And you can reference if you want it to behave as a client or as a server, but that refers to the host, right? The host will then receive that information and will create the ports accordingly to the mode reported by the administrator. So those differences are mainly this. In a high-level view, you have different OBS port types, both for DPDK support. One is vhost user, the one that I have shown you, and the other is vhost user client. So, that's very good, as it can allow the selection by default. This one is used. I mean, in 4.12, you cannot select it, but you will be used the server type. I forgot to switch. Actually, those needs to be switched. If it is vhost user mode server, the VM gets client. So I confused that. But from further reading this link. But basically, you get the idea. It's a parameter that tells the host how it should behave in terms of ports creation, OBS ports creation. Then also 4.13, in order to allow VM migrations, because it was not allowed to migrate VMs between DPDK hosts, we had to introduce a way to let the management server know when a VM is created with the DPDK support. But in order to do that, we need to let the management server know that the DPDK is enabled on that host. So to do that, when that property of the agent is set, then the KVM host sends the management server a new capability, which is for DPDK, and that will let the management server be aware of which KVM hosts are DPDK enabled. Because if not, on 4.12, you could not avoid using tags. Because if you didn't use your tags, then some deployments will end up on another host. So by doing that, it's pretty good, and that will be the base for live migration. And live migration is not as simple as that, because when migrating from one host to another, a new port with DPDK support needs to be added. So it's not simply selecting a host. That host must be a DPDK enabled one. It's to remove the host and plug it to the new port. So yeah, the live migration just will the management server, as you all know, it has a method to find suitable hosts. So for one DPDK enabled VM, it will try to find which hosts are suitable for that migration. That means which ones are DPDK enabled, and to for the management server to know which VMs are DPDK enabled, it will look at two things. The first is that it's running on a DPDK enabled host, and the second one is that it has the two configurations that I showed you previously, the huge pages and NUMA support. Okay, so to wrap up, I have shown you the initial support for this feature in 4.12, that it contains only the DPDK support with additional configurations. You can just deploy your VMs, but you cannot migrate them or do anything else. It can be just done. But in 4.12, there are more functionalities, and I hope that we can still get some more features. For example, this Lux UI part, it's just API. For example, not only for VMs, just for service offering details and displaying, you need to go to the API and display that. So this also works on NFS only. We need to extend to different types of storage. That would be good. Maybe some ideas to have a new type on the management server to see, instead of having a capability, maybe it would work a new host type or a new type of VMs. I know there could be many things in future for work. I will encourage you to give it a try and to try to propose new ideas or just contribute. And for further reading, I just left some links here. And also, these are the 3 pull requests with the functionalities I have mentioned previously. Those are already merged. So, yeah, I open now for questions.
So if I'm doing live migration and my host doesn't support DPDK, is it possible for the VM to just be migrated and just not have any?
Yes, currently on 4.13 that will be, yes. There's in the initial support, if your host did not support DPDK and you just try to deploy it, you will fail and you won't have to. But on 4.13 it is possible. So suppose that you want to deploy a DPDK enabled VM or migrate it. No, sorry, actually migration won't be possible. It's a pre-check that won't let you migrate. But if you want to deploy on a non-DPDK enabled, it won't fail. It will create your VM normally with open vSwitch work normally and will work, but won't have the DPDK backend support. I mean, it is possible for deployments and not like migration.
What about migration by itself?
We do not support it. No. But
I'm thinking, like, if we turn off the VM and migrate it to another host, and it doesn't support DPDK, just let it be.
I think that would work because it would start again and will do the same process. So that should work. The thing that was not working was live migration. Without turning off your VM, that shouldn't work. That wouldn't work before and now works. That is the improvement. So yeah, doing a normal migration will work. Yeah.
What's the dependency with NFS? Why? You said, if I understand that, it doesn't work with all storage time?
No.
Why? I see the link with NFS. What is actually being stored?
I don't know don't know. I haven't tested on another source, but yeah, I do not see the dependency right now. Maybe I'm missing something, but yeah. Sorry, let me check that later.
So it's untested. You didn't test
Yeah.
the side of it.
Yeah,
It's not
but I cannot think right now on how you can. I don't know. No?
I was wondering if you, why you have the split config between the service offering and the agent. I was thinking that, it would be possible to call out to the actual VIF driver on the agent, and, it's responsible for crafting the NIC portion of the domain XML, right? And so, what about like adding another method that gives the VIF driver the opportunity to add any extra configurations that it might need to support that specific networking, rather than it just seems a little bit heavy-handed from the user administrator perspective to have to maintain both configurations and make sure that they both match on the offering and on the destination host.
Okay, and how would you? Sorry, I lost the point. Your VIF driver, another method, but to do what?
So the agent, while it's crafting all of the domain XML for the VM,
Yep.
it calls the VIF driver. It does a plug,
Yeah.
and that creates the NIC, and if there's a bridge, and it calls out to this VIF driver the implementation to do the specific things that needs to go in host. And so my thought was, when it calls the OVS VIF driver, what if there were a function there that allowed it to add not just the NIC XML that's specific to the implementation, but any other XML that is required in the VM to do that NIC.
You mean for
That way
DPDK?
it's kind of all abstracted in the same place. The implementation is all in the VIF driver.
Okay, I got it. So for example, let me show you here. Like this. You mean that your VIF driver just plugs this into your VM?
Right, because it knows that, I'm doing a DPDK enabled NIC, and I also need to add this to the domain XML,
Yeah.
but then the admin doesn't have to go and get that perfect the service offering, which is like a totally separate configuration.
I do have some concern. As you see here, that is configurable as you want. You can specify the amount of memory, CPU. So that would be very arbitrary, right? So by doing it, you will need a way to first pass it maybe one time to the VIF driver, and then let the VIF driver flags it anytime. That could be a good improvement. But you first need to pass all this, because it's not something that, and also huge pages can be enabled with some parameters. So this is not something that is fixed. This is configurable, and it's up to the administrator. That's why we added the additional VM configurations, because it allows you to pass whatever you want. But yeah, I think it's a good improvement. If you firstly pass that to the KVM host, then that could be added to your VMs. Yeah. But you see my point that it's so arbitrary that it is not something that is fixed as it is for. I mean, it depends on what your needs are.
Yeah, and I can see it. Maybe someone would want to have some VMs that are DPDK enabled and some that are not, and not have to be like my whole cluster is DPDK.
That won't. That would be allowed for the 13. You can have mixed VMs.
I was just trying to think of a way to make it a little bit more seamless and easier for somebody to configure.
Looks good.
In your example right there, you got load host pass-through.
Yep.
Is that a requirement?
Yes.
You cannot use host model.
To answer your question, I did not test that again. We have tested with this. If it does support,
because otherwise host pass-through is
no, I think it will be extendable as long as the normal is supported. Then should be. Yeah. Let me briefly.
It would be good documenting.
If I go to the host, okay. Yeah, to answer your question, I use host mode.
So you have a graph there showing the performance differences between normal OVS,
Yeah.
OVS and OVS DPDK. Is there any comparisons between DPDK and just normal Canadian bridge?
I don't have other charts, but certainly you're asking DPDK against this normal bridge or OVS?
OVS DPDK versus just normal Canadian bridge.
I don't have the charts, but as I mentioned today, as it does it only passes through user space when needed, and you don't have the packages on your routing table, which is the fast path. It gets an improvement because it does not have to pass always through user space. But yeah, sorry, I don't have any charts.
And is this supported with just normal networks, or does it care about the VXLAN at all, or is any kind of vSwitch support works?
VXLAN is currently in the bridge with driver.
Yeah.
So it's not the OVS, but
OVS doesn't support multicast on these, so you have to do some crazy trickery to be able to know the multicast traffic.
Any other question, guys? Okay. So that would be it. Thank you, guys.